So this is a video explaining the questions on section 8.8 WSPM. And here are the notes. And on this section, we're doing the difference of two squares mainly. But then again, it says factor. You may have to use other factoring methods that we've learned. But as of right now, we are focusing in on this section 8.8, which is a difference of two perfect square terms. So if your first term is a perfect square and your last term is a perfect square, and there is no middle term, it's a binomial, and it's a difference, all you got to do is square root this guy, and plug them right into your answer format. Square root, plug them right there. And of course, if it's a minus, then these signs have to be different. Now, it doesn't have to be where your plus is first and your minus is second. It could be minus first and plus second, as long as they're different. So we have some examples that we did yesterday. Like right here, we have the difference of two perfect square terms. The square root of 81x squared is 9x. The square root of 16 is 4. So 9x and 4, 9x and 4. And of course, one has to be a plus, one has to be a minus. You could have switched them and put the minus and the plus. As long as they're different, it's good. Anyway, let's look at this worksheet. We do have a difference of two perfect square terms. So we are able to jump straight into the factored form format. Again, this is a perfect square term. You could actually do the square root of a squared. The square root and the square, they undo themselves, which means that you just have an a left right there as the first part of each binomial. And then you have a perfect square term here, and you could do the square root of 4, which is 2. So you have a 2 as the second part of each binomial. And of course, on the difference of two squares, in order to get that minus 4 at the end of your distribution, one has to be plus, one has to be minus. Doesn't matter which one you put plus, which one you put minus. That is correct. So let's move on to number 2. Right here we have n squared minus 64. So once again, you have a perfect square term. You have a perfect square term. So you could square root the n squared, which will eliminate the square and just leave n. And you could square root the 64, and that'll be an 8. So you have a binomial of n and 8 on both of them, n and 8. And of course, when you think of the signs that belong right here, they can't be the same sign, because imagine if this were a positive 8 and a positive 8. Positive 8 times positive 8 is not negative 64. In order for it to be a negative 64, the signs have to be different, okay? Not only that, they have to be different because there is no trinomial, it's a binomial. There's no middle term. So if you were distributing n times n is n squared, n times 8 is 8n, and then negative 8 times n, that'll be a negative 8n. That way the middle terms will cancel. That way you just get a binomial, not a trinomial. Anyway, let's move on. Number 3. This looks funky because it's not in standard form. We usually have the variable with the exponent first. But we could just do this as is, because this is a difference of two perfect square terms. You could actually do the square root of that perfect square number 1, and you could square root that 49d squared. So let's use our answer format, and let's actually square root 1. That's going to be a 1. And you could square root 49d squared. That's going to be a 7d. So you have a 1 and 7d on both. And of course, because there's a minus sign, actually you wouldn't be able to do this if there were a plus sign. But because this is a negative 49d squared, this has to be a negative 7d and a positive 7d. Or the opposite, plus, minus. Doesn't matter as long as the signs are different. Looking at number 4. Once again, it's out of order, right? If you want, you could put it in order, or you could just do it like that and square root and square root. But it might be nicer to put them in order, especially because you need the middle term to be a minus sign. So this is a plus sign. So it's better to put the p squared first and the minus 16 second. P squared first, minus 16 second. Then you could be like, oh, I could square root this and I could square root that and plug it into my factored form answer format. So the square root of p squared is p, and the square root of 16 is 4. And of course, the signs have to be different. 1 minus, 1 plus, or 1 plus, 1 minus. Okay. Right here, you're thinking, oh, these are perfect square terms. I could square root this, I could square root that. But the reality is you can't use this shortcut method. Why not? Because that's a plus sign. So right off the bat, not factorable. Okay, let's remember this. The notes remind us that it has to be a minus sign. It must be a difference of two squares. Difference means minus. It has to be minus. If it's plus, it's simply not factorable. Okay, so moving on to number 6. Right here, it is a difference, and they are two perfect square terms. So you could just do it as is right now. Okay, so you could put the parentheses. You could say, I'm going to square root this guy. Square root of 36 is 6. And I'm going to square root this guy. The square root of 100 is 10. And square root of w squared is w. So 10w. And the signs have to be different. One has to be plus, one has to be minus, or minus and plus. Okay. Is there other ways of doing this? Yes, there's other ways of doing this. I might as well show you an alternative way. Like, let's say you did want to write it in standard form, variable with exponent first before the 36. So imagine this. Okay, so this is already the answer right here. That's the answer. But another acceptable answer would be to switch your 100w squared. Let me correct myself. The minus 100w squared, put that in the front, and then the plus 36 second. So imagine if I put the negative 100w squared and then the plus 36 second. Well, first of all, right here, you have a plus sign and you want it to be a minus sign. You want a difference of two squares. So if you did want to organize it and put the w squared first, you would have to factor out a negative 1. That way, when you pull out a negative 1, negative 1 times what gets you back to a negative 100w squared. Then it would be a positive 100w squared. And then negative 1 times what will get you back to a positive 36. That would be a negative 36. And now that you factored out a negative 1, now you have a difference of two perfect square terms. So you could actually square root that 100w squared. And you could also square root that 36. So the square root of 100w squared is 10w. And the square root of 36 is 6. So you have a 10w and 6 on both binomials. And of course, because there's a minus sign, these have to be opposites. 1 plus, 1 minus. Don't forget to bring down that negative 1. So this is also an acceptable answer. But don't forget that there's a negative 1 out here in the front. Okay. So either of these answers is correct. This one definitely looks better because it's in order. The w term is first before the constant on the binomials. Number 7. So we do have a difference of two squares. In other words, you could square root this guy and you could square root that guy. And of course, you're going to plug it into your factored form answer format where one has to be a plus, one has to be a minus in between your binomials. So the square root of t squared is t. So you put a t as the first part of your binomials. The square root of 81u squared is 9u. 9u. And there's your factored form answer, t plus 9u, t minus 9u. Again, difference of two perfect square terms. So if you recognize we have two perfect square terms, simply square root that perfect square term. The square root of 4h squared, that is 2h. The square root of 25g squared is 5g. And again, one's plus, one's minus. Right here, we have, again, a difference of two squares. So all these are pretty much the same thing. Hopefully we understand it, that if you have a perfect square term, you could square root the front one, square root the back one, and plug it into your factored form answer format. The square root of 64m squared is 8m. The square root of 9y squared is 3y. And of course, the signs have to be different. Number 10, difference of two perfect square. Wait a minute. The 5 is not a perfect square term, so I cannot use this method. You can't pull out a GCF. You can't do anything with this. This is simply not factorable. Technically, you could also write the word prime But the bottom line is you cannot factor using this method of taking the square root because you need to have a perfect square term in the front and in the back. You do have it in the front. You could actually do the square root of this, but you cannot do the square root of 5. That becomes an irrational value, a crazy decimal. So can't do it. Moving on. Right here, we do have a perfect square term, perfect square term. However, we need it to be a difference of two perfect square terms. So one option is to factor out a -1. That way this will become positive and this will become negative, which is what we need. Or another option is to move the 4t to the front and the -49r squared to the back. Okay. I think I've done both before. I am going to factor out a -1. That way the inside now becomes a positive 49r squared, and it does become a minus 4t squared. Okay. So now if we look at the inside, we do have a difference of two perfect square terms, which means I could square root both of them and plug them into our factored form answer format, a binomial times a binomial. Then again, don't forget to bring down that -1. Okay, so what is the square root of 49r squared? I'm going to do this one in blue. Square root of 49r squared is 7r. So that'd be the first term of each binomial. And then the square root of 4t squared, I'm going to do that in red. That's going to be 2t. And you put that as the second part of each binomial. Okay, and of course, the signs have to be different. One has to be minus and the other one has to be plus, or plus and minus. And there's your final factored form answer. Again, you could have put this one in the front and this one in the back. You could have switched the order. That way it would have been a difference of two squares. But I think this is even better because it is in alphabetical order. R is before T's. But you could have done it the other way. Let's move on. Number 12 is an interesting one because they are not perfect square terms. You cannot square root the 8. You cannot square root the 72. So don't give up. Think of other factoring methods that we've learned in the past. The very first factoring method that we ever learned was to pull out the GCF. And that's what we should do. We should pull out the GCF and then look at the inside and see what else we could do. So we could pull out an actual 8, right? You could pull out an 8 from the first one because 8 times 1 gets you back to 8, and 8 times 9 gets you back to 72. So if we do pull out an 8, we will have x squared left over right there. 8 times x squared gets you back to 8x squared. 8 times what gets you back to negative 72p squared? Well, that would be a negative 9p squared. And now we do have a difference of two perfect square terms, okay? This, you could do the square root of that, and this, you could do the square root of that, right? So we could actually rewrite it in our factored form and simply take the square root of that x squared, which is x, and you could take the square root of 9p squared. The square root of 9 is 3. The square root of p squared is p. So the square root of 9p squared is actually 3p and 3p. And of course, the signs have to be different, 1 minus, 1 plus, or 1 plus, 1 minus. Don't forget about that original GCF of 8 that came out first. And there's your final factored form answer, 8 parenthesis x plus 3p parenthesis x minus 3p, close parenthesis. Moving on. So at the moment, we do have a difference, but they are not perfect square terms. You can't do the square root of 20. It's not a perfect square number. 5 is not a perfect square number. So you can't start by square rooting. So what's the first type of factoring we learned that we should always apply? It's pulling out the GCF. So if we pull out the GCF, in this case of the number 5, what would be left on the inside? That would be a 4q squared. And 5 times what gets you back to 5r squared? That would be a minus 1r squared, or just r squared. And now if you look at the inside of the parentheses, we could continue factoring because now we do have a difference of two perfect square terms. I could actually take the square root of 4q squared, and I could actually take the square root of r squared. So let's do that and plug it into our factored form answer format. The square root of 4q squared is 2q, and the square root of r squared is r. And of course, the signs have to be different, 1 plus, 1 minus. What about that 5 that you factored out, the GCF of 5 that you factored out originally? You have to bring that down, and here's your final factored form answer for number 13. Number 14, once again, you have a difference, and you have an a squared and b squared, but the 32 is not a perfect square number, the 50 is not a perfect square number. So we need to pull out the GCF because that's the only other thing we could do right now. and then we're going to look at the inside of the parentheses and see if we could continue. And if you think about it, 32 and 50, you might not see what they're both divisible by. You could at least divide them by 2, right? Because they're both even numbers, 32 and 50. So we could at least pull out a 2 and then see what's left over on the inside, see if we could pull out anything further. So 2 times what gets you 32? 2 times 16 gets you 32. And of course, you still have the a squared. 2 times what gets you back to 50b squared? 2 times negative 25b squared will get you back to negative 50b squared. So we factored out a 2. And if you look at the inside, yeah, there's nothing else to pull out, but it is a difference of 2 perfect square terms now. So you could actually square root this first term, square root the second term, and plug it into your factored form answer format. So here's our binomial times binomial, and let's actually do the square root of 16a squared. That'll become 4a, so you put a 4a as the first part of each of those binomials. And then you do the square root of 25b squared. That'll be 5b as the second part of each of those binomials. And of course, the signs have to be different. One has to be a minus, one has to be a plus, or plus and minus. What about that original GCF of 2 that we pulled out? Simply bring it down in your final factored form. So here's your answer for number 14. 2 times that binomial times that binomial. We are done with the first half of this video, which is just factoring. Maybe not the first half of the video, but first half of the worksheet. And then right here on the second half, there are all equations. Notice up here, there's no equal signs. No equal signs. Down here, all of them are equations. There's an equal sign. All of them, equations, equal sign, right? So what we need to remember on this second half of Unit 8 is that we love to have equations equal to 0. We love to have equations equal to 0. And why is that? Because we may be able to apply zero product property. And what is zero product property? It's if I have something times something and it equals 0, then that first something could equal 0. And the second something could also equal 0. So you create 2 simple equations. That's if you're able to rewrite this into something times something. So right here you have something minus something. So we're going to factor, and you could use any factoring methods you want, but right here you do have a difference of 2 perfect square terms, and that's what this section's all about. Recognizing that if you have a perfect square term right here, you could square root it and put it as a first part of each of your binomials. And if you have a perfect square term over here, you could square root it and put it as the second part. So the square root of 16x squared, that is 4x. So that would be the first part of that binomial, first part of that binomial. And then we have the square root of 9, which is 3. Put it as a second part of that binomial, as a second part of that binomial. And of course, the signs have to be different. One has to be plus, one has to be minus. Now, once again, the whole purpose of factoring this is to get something times something equal to 0. Again, we need it to equal 0. That way we could split them and solve and set them each equal to 0. So you're going to have this one on the left, 4x plus 3 equals 0. And then this one on the right, 4x minus 3 equal to 0. And you're going to solve both of these equations. We're going to subtract 3, subtract 3. You're going to end up with 4x equals negative 3. Final step would be to get rid of the multiplication of 4 by dividing by 4, dividing by 4. And then you'll get your final answer, x equals, you can't really divide negative 3 by 4, so you leave it, and that's a fraction. That's your answer, negative 3/4. You're going to do the same for the other one, but instead of minus 3, you're going to go plus 3 to get rid of the minus 3. What you do to one side, do to the other side. Rewrite it, 4x equals 3. Final step would be to divide by 4. Divide by 4, you're going to get x equals 3/4. So those are your 2 answers, negative 3/4 and positive 3/4. I might as well explain this right now. If you wanted to, you could use semester 1 method of solving equations. Back when we first started solving equations, it was all about getting x by itself on one side. And because we have only one single x, you could actually get that by itself. So let me show you an alternative way of doing 15. I'm just going to rewrite it right here on the side. 16x squared minus 9 equals 0. So I could have taken the minus 9 and moved it to the other side. Now you don't have to do this. We already solved it. We already have the answers. But when you rewrite it, you'll have 16x squared equals 9. And then you would want to get rid of this 16 in front of the x squared. You would divide by 16, and you would get x squared equals 9 over 16, okay? Now, when we solve an equation, you want to get x by itself, and you don't want this square, so you could undo the square by applying the opposite of a square, which is a square root. So if you do a square root to one side, you got to do a square root to the other side. So you will get x equals, no more x squared, it's just x equals. And whenever you apply a square root in an equation, you must put a plus or minus in front of your answer. However, we need to think about this. When you have the square root of 9 over 16, you could actually split the square root to be the square root of 9 over the square root of 16. So think about that. What is the square root of 9? That's 3, no more square root. What is the square root of 16? That's 4, no more square root. So that's why we get a final answer of x equals plus or minus 3/4. Notice that it's the same exact answer. X equals positive 3/4 and x equals negative 3/4. Here it is, positive 3/4, negative 3/4. Now, because we are focusing in on this factoring method of difference of two perfect square terms by square rooting, it may be a good idea just to stick to this factor, split it, solve it, get your two answers. But I wanted to let you know you could isolate x squared in this case because there are no other x's. Now, you could isolate x squared and then get rid of the square by doing a square root. But if you would have had another x, like 16x squared minus 9x, then you would not be able to do this method because there's two different types of x's. Anyway, let's move on. Right here, we have the difference of two squares. I'm not going to isolate the p. I'm just going to factor, split, and solve. So I do have a perfect square term here. I do have a perfect square term there. I want to jump right into my factored form answer format. The square root of 25p squared is 5p. The square root of 16 right here is 4. And of course, the signs have to be different, 1 minus, 1 plus. You still have the equal 0, which means that now you could split them and solve. Again, something times something equals 0. The first something could equal 0, and the second something could equal 0. So that's what I'm going to do. 5p minus 4, that could equal 0. 5p plus 4, that could equal 0. Okay. So when you're solving this, plus 4 here, plus 4 there, you're going to end up with 5p equals 4. For my final step, divide by 5, and p will equal 4/5 because you can't divide 4 by 5, so you just leave it like a fraction. If you did the same thing to the other one, minus 4 to get rid of the plus 4, you'll have a 5p equals negative 4. Final step would be to divide by 5, and p will equal negative 4/5. So I could have done this by isolating p and then applying a square root, but just remember that if you go that route, you have to put a plus or minus in front of your answer to actually get both of these positive 4/5 and negative 4/5. Let's move on. Here's another one, difference of two squares. We could square root this guy, we could square root that guy. So the square root of 36q squared is 6q. The square root of 49 is 7, still equal to 0. Again, one has to be plus, one has to be minus. And again, why do they have to be different signs? Because that's the only way. A positive 7 times a negative 7 will give you a negative 49. If they were both positive, that would give you a positive 49. If they were both negative, it would give you a positive 49. So the signs have to be different. Anyway, once you have it in factored form, you could split them and solve. 6q plus 7 equals 0. 6q minus 7 equals 0. So if you solve 1 plus 7, you're going to end up with 6q equaling 7. And then you would divide both sides by 6. And that'll give you q equals 7/6. And you do the same for the other, minus 7. You get 6q equals negative 7. Final step, divide by 6, which will give you your final answer, q equals negative 7/6. Again, you could have done it the other way. You could have added 49, moved it over here, divided by 36, done the square root of q squared to get rid of the square. but when you apply the square root, you have to put a plus or minus in front of your answer. That way you do end up with a positive 7/6 and a negative 7/6. Number 18 right here, again, we have a perfect square term here and a perfect square term there. Now, yes, it's not in standard form where your b is first and your number, your constant, it's at the end, but who cares? We could go with it. We could just square root 81, which gives you a 9. And you could square root 4b squared, which will give you a 2b. And it's still equal to 0, and you still have to have different signs, minus and plus. Now we could split this, set it equal to 0, and this set it equal to 0, and get your two different answers. So I have 9 minus 2b equals 0. 9 plus 2b equals 0. And when you solve this, subtract 9 to start getting b by itself. You're going to end up with negative 2b equaling negative 9. Final step would be to get rid of the multiplication of negative 2 by dividing by negative 2, dividing by negative 2. And you get your final answer. Negative divided by a negative is a positive. So you get b, that canceled out, equals positive 9 over 2. I mean, you could have technically written that as 4.5 or 4.5, but I'm going to leave it as an improper fraction, positive 9 over 2. Let's do the other one. Subtract 9, subtract 9. You end up with 2b equaling negative 9. And then we're going to divide by positive 2, divide by positive 2, and you will get b equals negative 9 divided by positive 2. So there are your two answers, positive 9 halves and negative 9 halves, or positive 4.5 and negative 4.5. So right here, we do have the option of moving this 4 over by subtracting 4 and subtracting 4, setting it equal to 0 so we could factor, then split it, and then solve. But you know what? We've been doing so many of those that I'm going to do it the alternative way. Since there's only one type of d, it's not like you have a d squared and a 4d where you have two different types of d's. We only have one type of d right here. So I'm going to choose to get d by itself and solve that way. Okay, so I'm going to get rid of the multiplication of 16 by dividing by 16 and dividing by 16. That'll cancel out. What do I have left? I have d squared equals 4 over 16. You could actually reduce that by 4. Divide by 4, divide by 4. You're going to end up with d squared equals 1 over 4. Okay, so now that I have a d squared and I don't want the square, I just want d by itself, I need to get rid of the square by applying the inverse operation. What's the opposite of a square? That would be a square root. So you square root here, square root there. You're going to end up with d equals, but when you do the square root of a fraction, you could split the square root to top and bottom. So let me do that right here. The square root of 1, square root of 4, and then you'll have your final answer that the square root of 1 is just the nice, beautiful number 1, and the square root of 4 is the nice, beautiful number 2. However, let's not forget that when we apply a square root on an equation, you must put a plus or minus in front of your answer. So d equals a positive 1/2 and also a negative 1/2. Okay? So I did not factor, split, and solve. I could have moved the 4 over to the other side and had 16 d squared minus 4 equals 0. And then I could have said, oh, that's a difference of two perfect square terms. And I could have done my parentheses, square rooted, and had a binomial times a binomial equals 0, and then split it. At the end of it all, I would have gotten the same answers. D equals positive 1/2, and the second one, d equals negative 1/2. Okay, so since the other one, I got a squared, or the variable by itself, and I got rid of the square by applying a square root, I want to go the other way. I want to make it equal to 0 first by subtracting 8, subtracting 8. You can't really subtract 8 from a squared, so you're just going to rewrite it. 18a squared minus 8 equals 0. Now, if this were a difference of two squares, I would be able to square root them, but this is not a perfect square term. That's not a perfect square term. So I need to think of something else, some other method of factoring. The very first type of factoring we ever learned was pulling out the GCF. And in this case, we could pull out what could we pull out? A 2, right? And if we pull out a 2, we would have a 9a squared. And you pull out a 2, you'd have a minus 4, okay? So technically, in here, we do have a difference of two perfect square terms, which means I'm able to factor using that shortcut of square rooting this first one. The square root of 9a squared is 3a. You put that as the first term of each of those binomials. And then the square root of 4 is 2. You're going to put that right here. Square root of 4 is 2. And of course, you have to have one positive and one negative. And it's still an equation. This equals 0 is still here. The only thing is that I changed this to become this, and let's not forget about that GCF of 2 that has to come down. So the 2 is still out there. Now, you could use zero product property here where it says something times something times something. Well, this could be 0 or this could be 0, but 2 is not 0, right? Even if you did say, well, could 2 equal 0? Like if you actually said, oh, 2 could equal 0. Nope, that's not true. That's impossible. But you do know that the 3a minus 2, that could equal 0, and 3a plus 2, that could equal 0, okay? And if you solve both of these, you'll get your two answers. So let's start by adding 2 to both sides. You will have 3a equals 2. Final step, divide by 3, and you will have a equals 2/3. On the other one, if you subtract 2, you're going to have 3a equals negative 2. And final step would be to divide by 3, and you will get a equals negative 2/3. Now, of course, I could have done this the other method, the way I did on number 19, which was to just get a squared by itself by dividing by 18, reducing this fraction, and then applying a square root to get rid of the square, and then you split the square root to the numerator and denominator, and you will end up with the answer 2/3, but you'd have to put a plus or minus right in front of it, because that's the only way to get both answers, the positive 2/3 and the negative 2/3. I think isolating the variable would have been faster, but that's what we did on 19. Let's move on. 21. Okay, so how about this? On this one, I want to get n by itself. All right, so I'm going to add 9 over 25, cancels out. Add 9 over 25. Look how much faster it is. N squared equals 9 over 25. Now you want to get rid of the square. You're going to apply the opposite inverse operation of a square, which is a square root. And when you do to one side, do to the other. So you're going to have n equals, don't forget to put a plus or minus in front of your answer. But of course, you're going to split that square root. So you're going to have square root of 9 over the square root of 25. And of course, the square root of 9 is 3. So we're going to put a 3 on the numerator of our answer. And the square root of 25 is 5. And of course, the plus or minus implies that you have two answers, n equals positive 3/5 and also n equals negative 3/5. So it's way faster to isolate the n instead of doing the factoring, splitting, and solving. But remember, you could only isolate n when there's only one type of n. Like if it were n squared plus another n, you wouldn't be able to get n by itself. So you'd have to go with the factoring method. So I am going to go with the quickest route here. I am going to get rid of the fraction, that minus 49 over 64. I'm going to go plus 49 over 64. And what I do to one side, do to the other, plus 49 over 64. So this does eliminate. And now you're going to have the equal sign, but instead of 0, you're going to have a positive 49 over 64. So here it is, 49 over 64. What do we have left? On the left side, we have the k squared. Bring that down. You have k squared. Now, again, we're solving by isolating, so you don't want the square on the k, you just want k, so you want to get rid of the square. So you're going to do the inverse operation of squaring. The opposite of squaring is square rooting. So you're going to apply a square root here, apply a square root there, and you will get k equals, but don't forget to put a plus or minus in front of your answer. And remember that you could split that root. Square root of 49 is 7, square root of 64 is 8, so you get a 7/8 as your final answer. Well, technically, k equals plus or minus 7/8, which means you have two answers, a positive 7/8 and a negative 7/8. Okay. You know what? I want to go with factoring this time, okay? Because technically I have a difference of two perfect square terms. Now you're thinking, what do you mean? This is not a perfect square term. Well, technically it is, because I could do the square root of this fraction. The square root of 1 is 1 and the square root of 25 is 5. Remember, doing the square root of a fraction is really splitting the square root and doing it to each of them. So you could do that, say, you know what, I want to jump right into my factored form answer format. I want to do the square root of this guy. And of course, the square root of that guy would be the square root of 1, which is 1, and the square root of 25, which is 5. And of course, the square root of h squared, which is h. So your first term of the first binomial is 1/5 h. The second term is 1/5 h. Okay. and then you do the square root of 16, that's going to be a 4. It's going to be a 4, and of course the signs have to be different, 1 minus 1 plus, or 1 plus 1 minus. And then now you have something times something equals 0. You could split them and set them each equal to 0. So you're going to have 1/5 h minus 4 equals 0. 1/5 h plus 4 equals 0. And you could solve each of them by adding 4, adding 4. That'll be 1/5 h equals 4. Final step would be to get rid of the fraction 1/5. And you could get rid of 1 divided by 5 by doing the opposite of dividing by 5, which would be multiplying by 5. So if you multiply by 5, that'll cancel out. But what you do to one side, do to the other, multiply by 5, and you'll end up with h equals, or 1h equals 20. Which implies if you do the same math to the other side, you're going to end up with a negative 20. So subtract 4 on both sides, you get 1/5 h equals negative 4. So yes, of course, you're going to multiply by 5, multiply by 5. And like I mentioned, h equals negative 20. So you have positive 20 and negative 20. If you would have isolated by getting h by itself, applying a square root on the square, you'd end up with h equals plus or minus 20 anyway. Moving on. Last one, thank God. I don't know, it depends if we want to get y by itself or if we want to move it over, set it equal to 0 and factor. I want to move it over, set it equal to 0 and factor. And of course, you could go any route you want. I'm going to subtract 81, subtract 81. I want to rewrite this 1 over 16 y squared minus 81 equals 0. And I know that this is a perfect square term because I could actually square root 1 and square root 16 and square root y squared. I could square root this whole term, and I could also square root this whole term and get 9 and plug it into my factored form answer format. Okay, so the first term, square rooted 1/16 y squared, the square root of that is 1 over 4y. 1 over 4y. And once again, because the square root of 1 is 1, the square root of 16 is 4, and the square root of y squared is y. So this is our first term on each of those binomials. And the second one's easy because the square root of 81 is 9. So I'm going to put a 9 right here and a 9 right there. And I know I need opposite signs, 1 plus, 1 minus. And now I could actually split them and solve. So 1 over 4y plus 9, that could equal 0. 1 over 4y minus 9, that could equal 0. And when I start solving the left equation, subtract 9, and you end up with 1/4 y equals negative 9. Final step would be to get rid of the fraction 1/4 by multiplying by the denominator of 4. That'll cancel out. But what you do to one side, do to the other, multiply by 4, you're going to get a final answer of y equals negative 36. And if you do the same for the other, plus 9, you end up with 1 over 4y equals positive 9. Multiply by 4 to get rid of the fraction, multiply by 4, what you do to one side, do to the other, y equals positive 36. And there's your answer, y equals plus or minus 36. Man, this has been too long of a video. We've finished every single question on this worksheet. 8.8 WSPM.